So, the plan to get room experts out to Proxima b? It's gonna take a while, especially with that huge $11 billion thing we're doing. If everything goes as it should take around 20 years to get there. So, we can't really guess if there's life there anytime soon, right? That deep space telescope? It's been key in figuring out if we're alone out there. It keeps giving us clues with what it finds. And the James Webb Telescope? It spotted some cool, almost human-made stuff way out there, getting us closer to that big question. Looking for life out there has kind of been a thing for us humans, right? We've made up tons of stories and ideas about it. It's just stuck in our heads. We always wonder what role and meaning we even have in the cosmos. It's like we're always looking for a buddy. Even if they're kinda like us, we still want to find answers. But even if we do get closer, can we even be sure those answers are what we really want? Or are they just messes? So, come explore with us as we slowly find new stuff in galaxies and planets and try to see something we might not even be ready for, and the glow of other worlds. Are the scientists close to something big? Way back when they were making the James Webb Space Telescope in 2021, someone asked a cool question: could our telescopes ever see lights made by aliens far away, like on Proxima b, that planet closest to us? Proxima b is about 4.25 light-years away and is probably stuck facing its star on one side and dark on the other, like our moon. Maybe they could use some tech to move power from the sunny side to the dark side with solar panels. One study, with a scientist named Manis Ving, thought that combining solar cells on the sunny side with future telescopes could work. This is pretty relevant now that we've got the James Webb Space Telescope. It would let us look for those lights on Proxima b and other planets. In fact, the James Webb Space Telescope might have already spotted those lights in 2024 because it's higher quality and much better, maybe kicking off a time of scientific stuff. We should check out exoplanets and galaxies in order to know how this project happened. The James Webb Space Telescope, JWST, is trying to find out how the universe started because we've wanted to know for so long. Since people wrote history down, they've wondered about where we stand in the universe, what we are, where we came from, and where we're going. These questions have been asked for centuries, even if they're tough. With new tech, we might be closer to answering them. If you asked a philosopher, they might say we're only just starting to get it. But if you asked an astronomer, they'd be stoked to tell you about the latest finds made with cool tools. People forget about these tools and what they represent. We have the world here for us, and we can spread our vision out around the universe. One way is to look at the work astronomers and space experts have done. They helped create new tech to find what might be light on those faraway planets. The James Webb Space Telescope is what helped them do that. It's an infrared space telescope, and it's here to kind of help answer the main questions and test the limits of what we can do. You might ask what Proxima b is. It's basically a super-Earth planet around an M-type star. Super-Earths are bigger than Earth but smaller than ice giants like Neptune. They're gassy or rocky, and some are twice as big as Earth or way bigger. Proxima b is one of these, and it's an exoplanet, so it goes around a star outside our solar system. We kinda thought we knew about exoplanets back in 1917, but no one really paid attention to it. Then, in 1992, we found the first one for sure, and experts were surprised. Another one that was detected in 1988 was confirmed in 2003. As of April 2024, there are 5,653 exoplanets confirmed with 4,161 planetary systems. 896 systems have multiple planets. Many are going around M-type stars. An M-type star is a red dwarf, the smallest kind of star. They're everywhere in the Milky Way, but they're not bright, which makes it hard to find planets. These stars have different types based on how big they are and how hot they are. Proxima b is about 1.07 times the Earth's mass. It only takes 11.2 days to orbit its star, compared to Earth's 365.25 days. You can figure out the size of the star Proxima b goes around by looking at the whole spectrum of light. The star's light is super dim, only 1.6% of the sun's brightness. And invisible light, it's only 5 to 6% of the sun, so it does not produce lots of light. Most of the energy, 85%, is infrared radiation. Proxima b is around 0.045 to 0.056 Australian dollars from its star. Proxima b was found in 2016. But why is it so different than the other stars and planets? Well, it's the closest known exoplanet to our Sun. While 4.2 light-years is far, it is still relatively closer. Proxima b is part of the Alpha Centauri star system, which is a triple star system. And even though it's dim, it's still one of the brightest objects in the night sky. Proxima b might be good to live on because it's right in the star's habitable zone where liquid water might exist. This has got a lot of space scientists excited and they want to check it out more. And that's where the James Webb Space Telescope comes in. It has 4 main goals: find light from the first stars and galaxies after the Big Bang, study the universe, look at how stars and planets are made, check out planetary systems and where life comes from. As the JWST looks at planets like Proxima b, we get closer to those goals. Looking for alien life is top on the list now, especially since, well, want to know. Spreading out there to the unknown is just what we do. It makes sense this mission is on such a large scale. Imagine it. The universe is huge. But we are the ones looking for signals from faraway people. It's like a game of hide and seek. These people are like spies, reading radio signals to seek any slight whispers outside of the Earth. Ever since the 1960s, humans began to look around the stars with very few real signals. It still inspires us to find things, especially because of the James Webb Space Telescope. Perhaps signals. Maybe they'll be ambiguous. Maybe these signals can be something larger. These detections and explorations could be where we go next and get to work. As we continue to seek, we can only hope one day we won't be alone in a universe. These lights can be quite literally steps into answering the many issues and mysteries the human face. So, the potential is huge, maybe beyond even understanding it. Could it evolve past the way we do? Could it force us to study our ways further? What will this all mean? These evolutions and situations are tough to face and may change everything we face. So we must face all scenarios with respect and understanding. Way back when the James Webb Space Telescope was being planned, someone wondered if our future telescopes could spot artificial lights on planets far away, like Proxima b, which is our closest planet outside our solar system. Proxima b is about 4.25 light-years away. It's probably tidally locked, meaning one side always faces its star, like our moon. One idea is that advanced tech could move energy from the sunny side to the dark side with solar panels powered by starlight. One study talked about how solar cells could maybe hook up with future telescopes. This is cool now because the James Webb Space Telescope is real, and it could help us look for artificial light on planets that are not in our solar system like Proxima b. The James Webb Space Telescope might have already found the lights that we are looking for by using better resolution and capabilities. We should get into how this happens to understand this. The James Webb Space Telescope's whole mission to explore Proxima b comes from our old interest regarding the universe. Since the beginning of time, people have been wondering where we fit in the universe, who we are, where we came from, and where we're going. These big, tough questions have been around for ages. But with tech getting better, are we any closer to answering them? If you ask a philosopher, they might say we're just starting to understand things. But an astronomer would be excited to tell you about the latest stuff discovered with fancy tools. These instruments we have represent what people can achieve. Now, the world is in our hands. And we should open up our minds and take it on with the same sureness. One of these is by space experts who help make the process of finding lights possible. The James Webb Space Telescope is key to this mission. This space telescope works towards those fundamental questions and expanding what's capable in space. So, what's Proxima b? It's a super-Earth planet orbiting a red dwarf star. Super-Earths are bigger than Earth but smaller than planets like Neptune or Uranus. They can be made of gas, rock, or both and come in different sizes. Proxima b is an exoplanet, so is not in our solar system. The first hint of an exoplanet was way back in 1917, but it wasn't a big deal. In 1992, the first exoplanet was confirmed, which surprised people. Another one found in 1988 was confirmed later in 2003. In 2024, we have 5,653 confirmed planets outside of our solar system and 4,161 planetary systems, with many having multiple planets. A lot of these orbit red dwarf stars. Red dwarfs are tiny stars. They are common in our Milky Way but don't shine, making them hard to find, and this makes it complicated to find planets. These stars are different according to their temperature, such as M dwarfs. Proxima b has 1.07 the mass of Earth. It circles its star in just 11.2 days, compared to Earth's 365. You can guess the size of Proxima b by looking at the light. The total amount of light is super small compared to the Sun. Proxima b was found in 2016. But why is everyone interested in Proxima b? Most importantly, Proxima b is the closest to our Sun. Even if 4.2 light-years means nothing, in the universe, it is near. Proxima b is part of the Alpha Centauri star system, a triple star system, and it remains bright in the night sky, only second to Sirius and Canopus. Proxima b is also possibly habitable since it's in the star's habitable zone, where water can exist. This got space scientists really interested. The James Webb Space Telescope joins in here. The goals of the JWST are to find light from the first stars, learn about how the universe and planets were shaped, and look at other planetary systems. As the JWST keeps checking out planets like Proxima b, we get closer to these goals. Search for extraterrestrial life is something the mission is working towards, as it goes to all people. Always investigating and looking. It is evident that such a mission will be brought about. It is a huge task to take on. The universe, with endless things, we are fortunate to be the ones hearing from people far away. The search for space intelligence can be looked at like a game of hide and seek, with people as the seeker and aliens hiding. These people are like detectives, reading sounds from others. This started in the 1960s. The search needs patience and most spans for a long time. Many signals haven't been received, but the possibility of planets like Proxima b gathers anticipation. This could allow us to secure the lives outside Earth. Or there are times we could have more things to ask. But the lights and signals are a turn for knowledge and technology. We expect to see lives outside Earth. The signals of planets like Proxima b will aid answering questions about Earth. As the James Webb Space Telescope carries on these, it may spark understanding the meaning of life and the universe. What would this mean? Will life and how that works go along our traits? If we just see the lights, there are meanings to it. In a way, intelligent people can change. It is scary, yet we have to face it carefully. Can we respond? How will people know? Should we be curious, but scientific? Will this create any chaos from beliefs, fear, or political issues? It showcases that events trigger changes. We have the roles to play if there are signs of other life or how their interactions are. There's no direct answers, we just must discuss as we continue to see the stars. The search for lives outside Earth will show humanity's future.